How to build a planet. Here we are on the small, water-covered rocky planet orbiting a medium-sized yellow star. We're one of 8 planets, all different from one another. The ones close to our sun are small and made of rock. The ones farther out are huge and made of gas. Orbiting the sun with them are many other smaller objects, comets, asteroids, lots of moons, planetary rings, things we used to think were planets, vast fields of planet-sized ice chunks, and tiny specks of dust. All of these things make up our solar system. And for a long time, we thought that's how all solar systems would look. But back in the 90s, we started to find out that wasn't true. Astronomers found giant gas planets so close to their stars that their atmospheres boil away into space. They found planets orbiting double star systems. They found super-Earths 10 times our own planet's mass. Why are these planetary systems so different? Is our little solar system a cosmic oddball? To find out, we need to know more about how planets form. And to do that, we need NASA's James Webb Space Telescope. To study the formation of stars and planets, astronomers look at the giant clouds of molecular gas and dust where new stars are still being born today. But when we turn our most powerful tool, the Hubble Space Telescope, on these clouds, we see mostly shadow. All that gas and dust cloaks the stars, blocking their light. But not all of their light. Visible light, the kind we see with our eyes, can't get through. But infrared light is different. Its wavelength penetrates gas and dust. Webb's infrared detecting instruments will capture infrared light as it emerges from the cloud, creating images that look through the gas and dust to reveal the warm, bright objects within. With Webb's help, we will be able to see both the newly forming stars and the disks of debris around them that eventually coalesce into planets. Webb will even detect newborn planets cocooned inside these disks. Normally, it's a real challenge to see planets around other stars. This is the best picture we have of one of these extrasolar planets, taken by the Hubble Space Telescope. No, not that. That's the star. The planet is, here. It's actually easier to see the dust around planets than the planets themselves, since there's so much dust spread out over such a vast area. This picture captures visible light from the star as it reflects off the planet and dust. But Webb's infrared vision will detect the inherent glow of these objects as they shine with their own infrared light. In fact, Webb will observe both gas and dust in exquisite detail around these young stars, studying and classifying showers of tiny pebbles as they ride lofting gaseous winds on a collision course with each other and eventually planetary destiny. Take a look at this animation. In the center is a heavy ball of gas in the process of becoming a sun-like star. Its gravity drags nearby gas and dust toward it. But because that gas is also zipping around the star, its motion balances the sun's pull and keeps it in a stable orbit. This also explains why Earth doesn't careen into the sun. Zooming into the disk, we see small particles in orbit. Because the star has drawn all this material together into the same space, things start to collide. Some particles stick together and develop a gravitational pull that collects more particles. Gradually, they form bigger and bigger objects, planets circling their own new sun. To identify the materials around the stars that are forming into planets, Webb uses a technique called spectroscopy. Webb captures the infrared light from the star and breaks it into colors. By studying the way some of the colors of light are blocked and filtered by this material, Webb can tell what the dust is made of. In fact, each atom and molecule has a unique spectroscopic signature. Webb can even use spectroscopy to look for water vapor, observing its presence both in planetary disks and in the atmosphere of existing planets. Astronomers are particularly interested in water because it's a requirement for life as we know it. They want to know which planets have water vapor and how water is carried to planets. By examining the birth of solar systems similar to ours, we glimpse the ancient history of our Earth. But Webb will do more than help us understand how our planet came to be. Astronomers now think that most of the stars in the galaxy have planets around them. We can't possibly measure or detect all of those planets, but by understanding how they form, we can begin to predict the diversity of planets out there, including how many Earths we can expect to find orbiting other stars.